explore the screen to find the hidden hotspots, or click on the icons. If you wish to change language, click on the Italian flag. A CDI application is produced in several stages. The first involves gathering together all your multimedia data, such as pictures, drawings, plots, text, numerical data, plus musical excerpts, audio captions, films, cartoons, and so on. And then converting them into CDI digital formats. Next, the application program required for accessing such data has to be defined and generated. Lastly, both the multimedia data and the application program have to be stored on the CDI disk, as prescribed in the Green Book specifications. HAL90 aims at simplifying the software production process by adopting a multimedia-oriented language, HAL, high-level authoring language, which can be used to describe titles in multimedia navigation terms rather than in terms of computer procedures. CDI differs from other audiovisual media in that, like compact disc audio, it is an internationally accepted standard. This means that any CDI disc will work in any player anywhere in the world. The CDI standard was established in 1987 and set out in the Green Book, the full CDI functional specifications. The applications developed with HAL90 are guaranteed to be fully compatible with the Green Book specifications. HAL90 provides a set of interactive multimedia situations known as IM models, interactive multimedia models, that give the designer plenty of scope for creating CDI applications without having to bother about trivial operational details. In fact, he is free to concentrate on the CDI project's most qualifying features, interactivity and navigation through structures of varying degrees of complexity, such as trees and nets of IM models. CDI Player, model for application developers. This version of the CDI player differs from the model available to the general public in the greater flexibility of its hardware parts. For example, you can use the machine with the internal optical player excluded and, connected to an emulator, control the CDI applications stored in the hard disk of the emulator itself. CDI Emulator. This tool enables the designer to create the image of a CDI disk and to store it on a 650 megabyte hard disk housed in the emulator itself. Then, using the data in the hard disk, the device emulates the standard optical CDI player. In this way, the designer can control the CDI application in normal operating conditions, without having to physically press the CDI optical disc. Once checked, if he wishes to press one copy of the CDI application onto optical disc, the emulator can be connected directly to a worm recording unit. The operating environment based on the MS-DOS personal computer is ideal for developing small and medium-sized CDI titles. A minimum configuration based on a 386 microprocessor at 25 MHz with 4 megabytes of RAM, plus a hard disk big enough to hold all the multimedia data necessary, or a connection to a network server, are sufficient for actuating all the stages of the authoring cycle, from the production of multimedia data to the conversion thereof into standard CDI formats, from the development of software applications to the creation of a disk image, and finally, the controls and tests via the emulation process. The audio production area deals with the sound part of a CDI title. All the background music, the spoken commentary, and the sound effects required are produced and converted into numerical form by means of professional equipment. Then, using special software programs, they are manipulated and adapted according to the requirements of the particular CDI title being produced. Lastly, they are converted into the standard CDI numerical audio formats using dedicated software programs available in the PC, Macintosh, and Sun operating environments. The software production area deals with the actual development of the CDI application, from the source code to the disk image. Thanks to HAL90's particular features and potential, this is the easiest stage of the whole production cycle. Once the disk image has been generated on hard disk, the CDI application performance can be controlled without having to physically press the optical disc by means of an emulation process. The video production area deals with the visual part of a CDI title. All the synthetic pictures, animations, and cartoons required are produced directly in numerical form by means of special software programs, whereas the illustrations and natural pictures have to be coded digitally after being captured from opaque originals or from photographic films by means of TV cameras or scanners connected to the computers via special graphic boards. Then, using special software programs, they are manipulated and adapted according to the requirements of the particular CDI title being produced. Lastly, they are converted into the standard CDI numerical video formats using dedicated software programs available in the PC, Macintosh, and Sun operating environments. In the master production area, the disk image generated in the software production area is used to press the CDI title in the required number of copies. For the production of a limited number of copies, for example for demos or prototypes, single copies of the CDI application can be produced directly on worm optical discs with a special recorder. For large-scale production, however, the disk image must be transferred onto a magnetic support, such as an exabyte tape, and sent to a factory specialized in pressing compact discs. To save time searching and loading pictures from the disk, the pre-loading facility calls up the pictures most likely to appear next and stores them in the CDI memory. Just click onto the icons to see the corresponding pictures displayed. Move the cursor from left to right or vice versa. You will see that it changes. In fact, with HAL90, the cursor changes shape and color according to the screen area. HAL90 provides numerous video effects for more dynamic viewing. Click on to the icons and see how they work on a couple of sample pictures. HAL90 provides numerous video effects for more. HAL90. HAL90 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 With HAL90, you can define different shaped hotspots within the same picture. The coloured spots in the picture you are looking at now indicate the basic shapes available. Try crossing them with the cursor. HAL90 also handles a stack of IM models. This means that the HAL90 code enables you to virtually pile the IM models up in the CDI memory as they are used, and then to call them up in the opposite order, according to a last in, first out logic. By clicking on to the push key shown in these pictures, you will put them at the top of the virtual pile created in the CDI memory. Whereas, by clicking on to the pop key, you will call up and display the last picture placed on the pile. Try it yourself. HAL90 or HAL90 can be used at several stages in the CDI disk creation process, thanks to its range of integrated software tools. For example, the Query user interface, which automatically produces an ASCII file containing the HAL code. This is the high-level application description in terms of IM models. Then there is the compiler, which reads the ASCII files in order to create object modules that use the powerful and flexible TLV or type length value formalism. Lastly, there is the linker, which, as its name suggests, links all the object files making up the application, resolving all references to data on the disk. To resolve these references, the linker uses the disk map produced by a special program called pre-master, which arranges all the data on the disk according to the Green Book specifications. The results of this writing, compiling and linking process is a code which is executed on the CDI player by a virtual CPU, a powerful program designed to manage the player's hardware resources. For example, optimizing search times on the disk by preloading the pictures which are most likely to be displayed. Explore the screen to find the hidden hotspots. In this simulation, by clicking onto the Edit button, you can see the HAL code of the IM model selected in the previous menu and listen to the explanations on its particular syntax. By clicking in this simulation, the make phase compiles, creates a script, and finally generates the image of the disk. Now you are ready to play. In this